Hi, and welcome to the Global AI Notes. My name is Alex. I am Microsoft AI MVP, and today we will see from the Vlad, he is also Microsoft AI MVP, a talk about LLMs, and perhaps we will end in RAG. So welcome, and we're starting right now. Hi Vlad, how are you? Nice to meet you.
Hi, Alex. I'm fine. I'm fine. Nice to meet you as well.
Thank you. Thank you for being to the Global AI Notes. And we welcome you from Romania today. And that's great. We are both AI MVPs and never met each other in person. And finally, we meet at the Global AI community. That's great for this one.
It's a good community.
Yes, sure. So you will talk about LLMs and also about RAG and building the search assistant. So I'm really excited about this one, and the stage is yours. Please welcome.
Thank you, Alex. Right. So I realize the title is such a big mouthful. So building your own search assistant, hands-on guide to internet connected AI tools. But what does it mean? Right. So one thing I've been trying to reproduce is having a smart search assistant that just does things for me that I do not want to do or do not care very much about doing, right? And of course, there's a lot of agents, a lot of systems that claim or try to do that. But I figured, why don't we take this step by step and start at the basics? And instead of just diving into a big, huge, unknown, complex library, just see what's in there, see what it would take for us to build our own search assistant, our own smart assistant, and then see how we can do it. And I'm gonna click here so that next works. Right. So a few words about myself to establish credibility. I'm a Microsoft MVP on AI. I write stuff at vladiliescu.net. I write more stuff on Blue Sky and LinkedIn. And I also founded the Gen AI Club, a Romanian-focused generative AI community. Again, what do we want? Well, I would like to be able to ask GPT-4o questions about events that have occurred after December 2023. As you know, that's pretty much the cutoff date for the training data. And well, how do we get that? That's a great question. As I mentioned, let's think step by step. We've seen how well just taking some time to think first works. You've seen that in the O series from OpenAI. You've seen that in DeepSeek. Now let's see it for human intelligence as well. So really think a lot. What are large language models, right? And I'm not going to go into the theory, but I'm just going to say how I see a large language model. And basically, I just see it as a for loop. It's a dramatic oversimplification, I know, but a for loop in which at each step you get the next most probable word, with some caveats, of course, and then the cycle repeats itself, right? So it's just a text prediction machine that has learned a lot of rules for how to generate text, but in essence, a text prediction machine. So, and the magic being this predict next word, which requires a model to be trained, right? It needs to know proper distribution. It needs to know how to predict this next word. So how would we do it? What a naive idea would be to just retrain the model, right? We have a lot of data. We want to give it updated data. People in the past have trained it, so it knows what to generate. Why don't we do it as well? What do they have that we don't, except billions in NVIDIA graphics card? Well, And now a visualization for how I see large language models, and they kind of look like this, right? So you have a big amorphous blob of text, yeah, which then gets prettier and prettier as it's fine-tuned, right? So you have the big amorphous blob, this being the result of unsupervised learning, right? This being the result of feeding virtually the entire internet, plus lots of terabytes of pirated books, wink, right? To model, training it, and getting something that kind of knows English, kind of knows how to predict text, but that is it's not particularly useful. And then tuning it, teaching it the rules, teaching it to answer questions, right? Because by default, a base model will not answer questions, but a supervised one that goes in into SFT training knows how to do that. Then applying reinforced learning techniques, right? Asking teams of evaluators to pick, is this answer good? Is this better? And retraining. And it's such a huge pipeline and amount of work to get something good. But we must remember, this is what's beneath. Right, so just a quick example to make an idea of what's the difference between a base model and let's say a chat model, right? Pioneered by ChatGPT. Right, if I were to ask a base model, how does Hamlet's famous monologue start? It would just see this as a example of a question, and then it would start generating other questions, because that's what, when you have one question, you always can use more, right? So that would be a base model, not particularly useful, right? But then with fine-tuning and teaching the models the rules that, okay, when you're asked something, you should answer, not try to autocomplete stuff. You're better than a smart keyboard, right? It starts to learn. It starts to learn how to answer things. It starts to learn how to access its vast knowledge base, right? So where I'm getting at is that it's quite difficult to do a full retrain, right? And it's expensive. It doesn't really make sense to do one. All right, but we want to feed a model recent data, right? So what else? I've heard about fine tuning. Yeah, we've talked about supervised fine tuning. That's a fine tuning. Fine tuning must do some good, right? And here I've stolen a slide from the Llama 2, which was like a lifetime ago. But still, I think it's a good pipeline and a good way to visualize the process, what goes into building this model, right? So we have some pre-training data. You have the Llama 2 base, which basically the amorphous blob, and then you get into a cycle that takes supervised fine-tuning and then reinforcement learning and applies and reapplies everything. So we would be looking at this bit right here. And how does a fine-tuning data set look like, right? What are we talking about? Well, I've added a screenshot here of a pretty cool data set, let's say, OpenORCA. So this is based on the ORCA paper from Microsoft. But this is an open data set, right? You can use it, you can fine-tune your own models. And here you can see what goes into fine-tuning such a model, right? You get a system prompt, right? Which gives the model personality, as you know. And then you get a question and the expected response, right? So now the models are trained to understand that, okay, given this personality traits and this question, I should output stuff like that looks like this, right? And 4.2 million rows later, it kind of does. But okay, of course, this approach comes with some other issues, right? again, we want to train something on to answer recent questions, but then gathering the data set of all text on the internet is quite a task, Plus, it still takes a lot of time, right? So then, as soon as you fine tune something, it's already obsolete. We need it real time, right? This isn't real time. So let's see what other options are there, right? It's back to the drawing board. And now in hot pink, so everybody remembers, yeah, what if we include the information in the prompt, right? What if we act like a benevolent teacher that when grading their students just suggests the right answer. I had a teacher like this once. It was terrible because I actually had learned for that exam and my colleagues didn't. Very frustrating. We all passed. Right, so, but speaking of this, we should know a bit more about context window sizes. Right, what is this? What context window? Is it from Microsoft? No, not necessarily. Right, so context window size is how much a model can, the cumulative length in, well, let's say in tokens, in words, that a model can ingest and output, right? Because it's it's the same number, right? So in the beginning, right, we can recall earlier models that didn't have a lot of context, right? We have GPT 3.5 or Llama 2, 4K tokens. Only 4,000 words would fit, both input and output. Yeah, and then GPT-4, 8,000. And then things started exploding. Yeah, with the latest models, you get from 128,000 tokens to around 2 million, which is crazy. Of course, with some caveats in that, in some cases, the retention across this context, the retention of the model is not as good. So from various research, depending on the model, you get facts that are stated at the beginning of the context that are better remembered, or at the end, but not most likely not at the middle. So you need to take that into account when placing lots of things into a model's context and then just hoping for the best. It doesn't necessarily work like this, right? But it's an evolution. It's getting bigger and bigger, but still it's finite, right? So it ends, right? The internet virtually is not as finite as a model's context, let's say. So we need another approach, right? And here's a crazy idea. What if we don't send it everything? And yeah, well, question is then, what do you send if you don't send it everything? Because it's easy to send it everything, assuming you have everything. But if you have every language, if you have everything and need to decide what to send it, then how do you know? Well, it's basically a search problem, right? And I'm guessing that's a word a lot of you have been waiting for and know about. It's retrieval augmented generation, right? What does that mean? It's generation augmented by retrieval. It's a search problem, and then you search for the right, you analyze the question the user asked, you search for it in your knowledge database, whatever that is, and then just return the bits and pieces to the LLM and have it generate a good answer, right? And I've borrowed this from the Azure docs, and this is, let's say, how a RAG system would work, like with Azure, with Azure resources, let's say, right? So you get from the user, you would get a query, and you would have your search engine process that query and look for it wherever, in whatever knowledge base you have. And then, armed with that knowledge, you would just ask your LLM, okay, answer this question given this data. And this doesn't sound like a bad idea, actually, right? This is a sample prompt, right? You are a search assistant, you help users, you've been asked this question, think carefully, blah, 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 answer from this. And that's it. Of course, there are lots of optimizations here, right? And we'll get into some of them in a moment. But one thing to remember is that if your search is bad, nothing helps, right? Because the LLM shouldn't make things up, right? So you need to be really good at search. But then, what does it mean to be good at search? So now we have the problem of semantic versus lexical. And as you know, with embeddings, you can do semantic search, which is awesome, right? You can see what bits and pieces in your knowledge base are semantically similar to the user's query, which is great when it works, not as great when it doesn't work, but such is life, right? So that would be semantic search, whereas lexical search is you just look at the words. You search for the word, maybe you do an or, maybe you do an and, get those results. It's faster, more deterministic. But if the user uses French and you have a database of English words, maybe it wouldn't work as well unless they're searching for a croissant. Right. So a good approach here would be to use hybrid search, right? Mix semantic search, mix semantic and lexical search. Maybe run them both at the same time, and then just combine the results, right? Using some specialized models called re-rankers, but not going into that a lot. But just so you know, this would perform best, right? Both types of search, because it's a search problem. Use both types of search, maybe reshuffle the results a bit, pick a top 10, top K, whatever, feed that to the LLM. Do we need really all of that just to be able to search on the internet? We might, but I remember distinctly when Boris Power posted this on what used to be called Twitter, right? And you can it's really cheap to embed the entire internet, because we all know the internet always stays the same, right? Really cheap to embed the internet. Who wants to take on Google? And I realized the answer is not me. I do not want to take on Google. So here's an idea. Why not just use a search engine to get what data we want, right? It's a problem of search. There's smarter people working on this problem, so why not do that, right? Why not use a search engine? And now I would like to show you a bit of a demo using a search engine. But first, I wanted to touch a bit the problem of long context versus RAG, right? Because I see a lot of enthusiastic people, and I used to be one of them. Now I'm reevaluating my position. So a lot of enthusiastic people about long context. Okay, who's going to need RAG? Who's going to need to do search if you can just fit everything in the context? But then you realize that everything is a very big word. It's like this big, very big. For example, one project I'm working on includes doing search on books of thousands of pages. And realistically, you can't really fit, I don't know, 20 such books into whatever you want to fit them in, right? It won't work as well. The retention won't work as well. So then you need to do search. You need to pre-process those documents. You need to extract the data, maybe using some smarter form of RAG, like graph RAG, which is great. You should totally read up about it if you haven't, right? It's about building a graph, a tree of knowledge, right? Allowing you to do some rudimentary search first and then go into depth. But you need some sort of a RAG system for this. But then for smaller knowledge bases, let's say, long context would work very well because it decreases the complexity. But it basically depends, right? But let's see how this works in practice, I'd say. So I'm gonna switch over to trusty old VS Code, and you know, in the beginning, I wanted to show you a very manual way to search this, like pretty step by step. Then I figured I'm having so much fun with this little library from Hugging Face. I wanted to show you this first. See where it works, where it doesn't. So I wanted to build an agent that answered this question for me, right? And this is it. This is my code. Just as an intro, I'm using small agents from Hugging Face. There's a lot of agent libraries. One thing I like about this is that it expresses their plans. So agents need a plan, right? They need to create a list of actions to take. But the novel part of this is they express their plan in code, right? So not JSON, not XML, not whatever, not YAML. Plain code, it's Python, which is good and bad news. The good news, way more expressive. The LLMs are trained on a lot of code, so then you get an agent that's really capable at writing code, following its instructions with written code, but then you're running Python code generated by an LLM with no supervision on your machine. Good news, bad news, right? I'm gonna do it. I'm gonna run Python code generated by an LLM on my machine. The thing that makes me feel slightly better is that they really limit the list of imports in that code. So it's not like it cannot import OS, for example. It cannot remove my Dropbox folder. And that's all you need to do. By the way, this is I'm using a connection to Azure OpenAI. This has been in place for about 3 weeks when they accepted my PR, adding it. So I'm just creating a basic agent. I'm telling it 2 things. All right, you're an agent. You have access to, in this case, a GPT-4o instance, and you have access to 2 tools. So it can write itself some little code and can do a web search, and also it can visit a web page. And I just tell it, okay, tell me what Vlad Iliescu is writing about. And let's see how it works. So you'll see it decides, okay, let's look for the Vlad Iliescu blog. Good approach. It actually finds it. Really good. I'm having a lot of troubles with DuckDuckGo. It's if you add some bad words like blog site, you can't find my blog. It's fantastic. Right, so it identifies that this is the list of my posts. Okay, and you see, this is the code it generates. This is what it runs. Blah, 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 a lot of results, and it gets the final answer correct. The latest blog post, it's how to configure Ada and continue with O3 Mini and DeepSeek. And let's check. This is my website. Yes, that's exactly the last post. It did good. If I ask it to summarize it, though, you might get a slightly worse response. So just to show you this. So it was fantastic that it worked. It was not fast. It took some tokens. It cost a bit, but it worked, and I'm really excited about this use case for agents. But let's see this. So I tell it, okay, not just infer this, not just infer the subject, but actually read and tell me what's in there. So now it's Vlad Iliescu latest blog post, and you can see the search doesn't work as well. It gets my LinkedIn account with GitHub Copilot. So I wrote about GitHub Copilot about 3 years ago, so you can imagine how fresh this data is. Right, executing parsed code, it decides to visit that blog post. Okay, reads it. That's awesome. And it sees something else, which is fantastic. So now you see the downside of using agents, right? You see one case in which it worked dramatically, and it should have worked here as well, right? Because if you can find a summary of an article, surely you can also read that page and generate a better summary. It failed. So my point being that agents are useful, but maybe a little more control would help. And that's not to bash on small agents. Again, I really like it. This is a problem with all agents at the moment. And now I want to show you a more, let's say, more manual approach. Advantage, disadvantage. Right? So for the manual approach, I wrote some code, right? So a bit of a setup. Yeah, just building manually, no LangChain, no nothing, just using the Azure OpenAI client, defining a method that allows me to invoke that client, and also a method called get Google results, which goes to DuckDuckGo, because sometimes I forget to rename things. But that's it, right? That's what we're defined. And just a quick test. If I were to ask an LLM, yeah, GPT-4o, about what my latest blog post is about, of course, I cannot provide real-time information, so on and so on. Let's take that agent thing and see how we can do it manually, right? So a first step would be to optimize the query, and I'm going to do that with an LLM. So instead of this, I get Vlad Iliescu latest blog post topic, which it's not necessarily a better query, but the LLM thinks so. And then let's scrape Google manually. And take the first link, which is my posts. It should work well so far, right? Now, what I'm doing is, and I think you've seen the same thing from small agents, is if we were to just take the web page and feed it to the LLM, it would be really, really big. So you see, in my case, the unprocessed page weighed at about 34 kilos and counted about 9,000 tokens, which is not ideal. But since I'm converting it to Markdown, and I'm using that because Markdown also allows it to keep a hierarchical structure, then I get a way lighter payload and more tokens left for the back and forth, right? And the chatbot, well, as you've seen before, I'm using a really similar format. You are search assistant. Okay, this is the query, this is the title, some reference metadata for the documents, and some helper function. And now let's create a chatbot. This is the simplest chatbot that I can talk to right here. So tell me what Vlad Iliescu's latest blog post is about. His latest blog post is how to configure. Oh yeah, that's cool. But this is not an agent, right? It's a workflow. I programmed it myself. So I can't just say it, summarize, please. Or, I can say it, but then it just responds with the context it has, right? It doesn't go off. If it were to go off on a tangent and visit pages on the internet, I would have to bake that functionality in myself, right? But this is a nice, let's say, comparison on what you can do with an agent. So you can do a lot, but it will fail in some cases, and what you can do with with plain code by creating workflows. I think that's important. In some cases, an agent will help or not, but in other cases, we can just get away with using a simple workflow and move forward. I do think we're kind of running out of time. So I just want to say thank you for watching this, and not sure if there are any questions.
Yes, they are. Thank you very much for the
Awesome.
great explanation. And the first question is, it was really fun explanation of LLMs. So just so, as you said, okay, that is only one code, and then that's it. Let's go through this one. You showed the reg on one page from Azure AI Search, and it was also during the build we showed this one to the in labs 2 years ago, 2024, and the people they're gone crazy. They wanted to use Azure AI and provide on their own company data. So, for example, SharePoint site or blob storage or whatever. Are there any limitations for what you showed us? You showed one agent. What if about if I want to have several agents, they're talking to each other?
I was so that's, on the one hand, that's an engineering problem, of course, because you can have multiple agents. You can just code them yourself, or have them exposed via an API and talking with each other. But on the other hand, I know, and I've been reading a bit about, Microsoft has a project called Tiny Troop, which is exactly focused on this. So it's mind blowing. It allows you to build simulations. Right, so you can have a marketing team with a marketing director, and several, I don't know, interns or whatnot, and ask them questions or give them tasks and look at the dialogue between them and how they solve them. So this is great, and I'm sorry I haven't had the time to look into this more, because it's fascinating.
Yeah, sure. Of course. One question was, is your code available on GitHub or somewhere else? So do you post your code on your blog perhaps?
I do need to check. It should be on my blog, but I do need to check. Is there any way to get in touch with the audience later, or maybe adding it to the YouTube description?
Yeah, perhaps we can just show up. So if you want to connect, just go for Vlad for his blog, and perhaps you will find their LinkedIn profile, also GitHub link, and so on. It was just a question. We had more than 300 people inside the call, and you do not.
Awesome.
You did not lose the people there. They were interested till the end. It were more and more people coming there, and that's why it's if there are some people that are new to the material for notebooks, whatever, Python code, whatever. Was a question if there's something material available there from your side, how to start on this.
I will. So, full disclosure, I have a previous version of this code on GitHub, but this exact version isn't, because I like to tinker. And I tinkered until the very end. So, but here's how we'll do it. I'll post the latest version of the code on GitHub, and then tomorrow it'll be live. So just go to my webpage and find the GitHub link there, and
that's great.
It's in there.
What do you say about the Copilot and agent discussion? What is an agent for you? What is a Copilot?
Man, that's. I have the greatest example. So right now I'm experimenting with AI assisted coding, right? And I've been using Continue and the GitHub Copilot for quite some time. So Continue is an open source extension that allows you to connect to a lot of models, including from Azure OpenAI, from whatever. Most importantly, it allows you to control the model you select. So I can just chat with O1 or O3 or DeepSeek or whatever. So that to me is an assistant, is a copilot. I can just say, okay, I'm editing this project. Take a look at these files. Tell me what's wrong, or summarize them, or implement this bit.
Yeah, sure.
But it doesn't do it itself, right? It's a chat interface. So then I need to, it's a sidebar. I take the code there, or just click insert, and it works. Whereas I'm also using, I'm experimenting with Aider. Not sure if you know Aider. It's
No.
an open source project, really cool. But it's basically an agent that can also connect to a lot of things. You run it on the command line, and it will. You tell it what you want to do, decides what to do, makes modifications, commits it to Git. It's in there, and in some cases it works. In other cases, it fails so bad. But to me, that's an agent. So you tell it something, and then it has agency. It does things by itself. Whereas in chat, I kind of have control. So I'm still trying to decide what I like, what I don't. But I maybe I'm old, but I prefer the chat metaphor for now.
That's great. That's great. So I would post your LinkedIn profile, your LinkedIn link in the chat. So for more questions, please reach out to Vlad. And
Sure.
Thank you for being with us today, right now. And you see the link from Vlad is here. And that's great. We had a lot of people inside the call. It was really interesting to meet you. And thank you for the Global AI Notes today.
Thank you, Alex.
Have a nice
It's
day.
been great. You too. And thank
Bye-bye.
you, everyone. Cheers.
Thank you.